Hello and welcome. In this tutorial, we will create a gradient field to distort a texture. So before we start patching, maybe we should clarify what we're trying to achieve here. We will generate a gradient field from an input texture, which will then act as a force map to distort a second texture. And this gradient field will essentially produce a bunch of vectors, which we can then use to distort the UV coordinates of the second texture. And with this, we can simulate the light refraction through a glass-like surface or through liquids or something like that. I recently came across a great touch designer tutorial by PPPANIK called Liquid Image Displacement. I will put the link into the description. And they're using the slope top in Touch Designer to achieve this effect. By the way, I can highly recommend all of their tutorials. Even if you're not using Touch Designer, you can learn a lot by just implementing all the concepts in Jitter, like we're doing now. So yeah, they're using the slope top in Touch Designer, which we don't have in Max, so we'll create our own implementation of this. Yeah, this tutorial consists of 3 parts. The first one is getting the gradient field. Second one is using it to sample another texture. And the third one is creating our glass-like window texture to use this effect with. I will start with an almost empty max patch. I have a jit.world object here, which acts as the rendering context. Here we have a jit.p window, so we can see what we're doing. And here is just an input video. So starting with the gradient field, I will use a jit.gl.pix codebox object. And by the way, there's also a great amazing max stuff tutorial on creating this gradient field. I will also put a link to this video in the description. I'll plug this in here so we can see what we're doing. So yeah, how to get the gradient field. The gradient field is essentially the slope, so the difference between a pixel and all of its neighbors. So the neighbors in the x direction, so left and right, and the neighbors in the y direction, so up and down. So to get the immediate neighbor of a pixel, we will just sample the pixel with an offset of 1 pixel in the corresponding direction. So to do this, we first need the size of 1 pixel. To get this, I can just divide 1 by the whole dimension of the incoming texture. And then I can say, okay, the left neighbor is going to be our input pixel at its incoming position plus an offset. And the offset in this case is another 2D vector. So to the left means we have the size of 1 pixel in the x direction and 0 offset in the y direction. And I'm using this nearest operator here instead of the sample operator. Difference being that the sample operator would interpolate between pixels and the nearest operator just gives us the nearest pixel corresponding to the coordinates we're inputting. Yeah, so this is left. Then to get the pixel on the right, I can put a minus here. And of course, I have to declare it right. Then I can just copy this. We can call this one up and down. So we're doing the same thing for the y direction. So we have 0 displacement in the X direction and 1 pixel in the Y direction, and the same here. The only difference being that here we're adding it and here we're subtracting it. So this is essentially what we want. So we can say output 1 equals a new vector. And for the red channel, we will say this is left minus right. And for the, oh no, that's wrong. And for the green channel, we will say this is up minus down. So in the in the X channel, we have kind of the difference or the slope for our X direction, and in the green channel we have the slope for the Y direction. This should theoretically already be working. Okay, we can see something's going on here. So I will shortly show you the original video. Plugging this back in here, it's kind of hard to see what's happening, so I will multiply this by a factor of 10 so we can see what's happening. So you can see here, every time this picture is bright red, we know that there is a contrast or a sharp contrast in the X direction, and every time it's green, there's a contrast in the Y direction. So this is essentially our gradient field. I will put this here, and now we can use this to displace the texture. So to do this, I will use a trigger list object, so I can send this texture to 2 different destinations. It is not necessary to do this, but I just like when things look tidy. So I could just do something like this, send it here, send it here. So the order of operations doesn't really matter so much with this. So now we're using it to create an offset when we're sampling this texture that's coming in here. I will plug this in here. So the output of this jit.gl.pix is just sampling the input that's coming in here at the normalized coordinates. So this is, again, the original picture, but now we can introduce an offset with input 2, and the offset is going to be our gradient field. Now you can see every time there's a sharp contrast, we have a bigger displacement going on, and when there is no contrast or low contrast, there is not much of a displacement going on. So this is already a pretty cool effect, but we're not done yet. It's not the effect we're going for. This is just to illustrate what's happening. So I will put this down here. We can put this one here, and now we can continue with part 3. And in part 3, I want to create this window looking grid texture. So to create our grid texture, I will again use a jit.gl.pix code box. So this one is the gradient field. I will also put a comment down here. This one is the sampling, and this is the glass texture. Yeah, so as I said, I want to create a glass that looks like a grid. So to create this grid, I would just put this output directly into our jit.world so we can see what we're doing. So to create the grid, first I need a parameter to define the size of the grid. So let's just call it grid and say the grid will be, I don't know, 16 by 9. And then we can say out1 equals, how will I do this? Let's start with our UV coordinates. So the UV coordinates are just the normalized coordinates. So ranging from 0 to 1 in the x and y direction. So yeah, 0 to 1 in the x direction represented by red channel, 0 to 1 in the y direction represented by the green channel. So now when I'm multiplying this one by our grid, you can see that, of course, now it's not ranging from 0 to 1, but from 0 to 16 and from 0 to 9. To get it back in the range of 0 to 1, we can use the modulo operator, so it will wrap around every time this value goes over 1. And now we have a lot of squares here. I think I will still need more space down here. So let's put this down here. Let's put this here. Yeah. So for our grid, I also need a parameter. Let's call it width. Let's say this is 0.5. So we can change the width of the grid. So to apply this, I could do something like, let's call this one just x and say x equals our uv.x when it is bigger than this width. This will essentially cover the image white when the coordinates are bigger than 0.5 and black when they're smaller than 0.5. So we can just check this one here. So yeah, when it's bigger, it's white. So we can also access this from out here. So you can see how the grid is changing. We can then do the same thing for our y coordinates. So this is the same for y. And now to combine this, I can say I want the maximum of x and y. So depending on which of them is bigger, I want to output the bigger one. And now you can see we have both of them. I can also access the width and then change our grid. So we could already use this one, but the problem with this one is that we have a very sharp contrast. So there is no gradient between the two colors. So they're either black or white. Let's have a quick look. I have to plug this one in here. So we don't see anything here because we're either displacing it by 1 or by 0, and displacing this by 1 would mean that the whole thing essentially wraps around, so we don't see any change here. So if I'm multiplying this by 0.5, okay, nothing's happening. Why don't we see anything? Let's see what's coming out of here. Ah, okay, the number has to be even smaller. So now you can see that the grid is applied, but it's only applied for 1 pixel because the contrast is very high. So I will again put this in here. So to change this, we need to apply some kind of a smoothing function to the whole thing so that we don't have a sharp contrast between black and white, but a gradient. And to do this, we can use a so-called smooth step function. And with the smooth step function, we're introducing a smooth interpolation between 2 values. So the smooth step function has 3 parameters. The first one is the lower edge, the second one is the upper edge, and then the interpolation between those 2 numbers. So how can we apply this? We can say something like x equals smooth step of, so the lower bound will be our width. The upper bound is just the maximum, which is 1, and then we're interpolating between them by our UV coordinates. So let's just put out our X here. I have to specify which channel. And now you can see, changing the width, that we get a smooth interpolation. So we could already be using this one. It's kind of what I want, but not exactly. So I think this is a good time to introduce another parameter, which we will call, I don't know, let's say amount. So we can then multiply this by the amount to change the amount of displacement. So you can see it's just this just controls how much we're displacing the texture. But again, plugging this one here, we can see that the smoothing only goes into one direction, and then we again have this harsh contrast. So to have smoothing in both directions, I will just say that we're subtracting this one, and instead of going from 0 to 1, we're going from 1 to 0. No, now I have to add this. Yeah. So we have a smooth interpolation from 0 to 1, and here we have a smooth interpolation from 1 to 0 because we're subtracting this one. And now you can see that this gradient goes in both directions. And now we can do the same thing for our Y. We have to change Y here and Y here. And then again, we take the maximum of X and Y like we did before. And now we have this smooth grid. Now we can apply this here. Maybe I will make this a bit bigger. And now it looks like we're looking through a textured glass. But something is not quite right. Let's just debug this for a second. So this is looking right. This is also looking right. What's the problem here? I can only see this in the positive direction and not the negative direction. Something's... oh. I have to get rid of this times 10. Yeah, it still only goes into one direction. Why is that? Maybe because I also have to apply X and Y down here. Yeah, okay, now. I have to apply the bound mode here. So I have to say bound mode equals clamp, so it doesn't wrap around. I will just copy this, put it here, here, and here. So, okay, maybe this one down here. So, yeah, I will add a noise texture now. So, because this is looking very clean, not like real glass, so I will add a noise texture to get it to look more like glass. So, where to put it? It's getting pretty crowded here. Okay, I will do something like this. I will put this one down here. Then I have some space left up here. I will create a texture. Let's make this one full HD. Let's say depth 0. And let's put a linear filter on this. So, where to put everything? Okay, I can put this here. Can put these here, and then can say jit.noise. One plane, float 32. Let's say this one is, I don't know, 1000 by 1000. Stop this for a moment. Nope. In here. And then we can initialize this with a load bang. Now we have a noise texture. I'm running out of space. Okay, I will have another parameter, call this one noise amount. Set this to a very small number, something like 001. Then I can also control this one from outside of the code box. And then I can say noise texture equals input 1 times the noise amount we have here. And then we can add this down here. Yeah, so this is the effect I was going for. Can increase the noise amount. Now this one doesn't seem to be working. What's happening? Ah, I know. We need to bang this one constantly. Otherwise, our changes won't be applied. So now it should be working. Yeah. You can see this is just noise going down with the noise like 001. Here we can change the width. And now we can also change the amount of displacement in the negative direction and in the positive direction. And now it looks like we're looking through a glass. And you can see if I'm using this to debug, you can see we have a gradient here, and the more contrast we have, the more displacement we have going on here. Yeah, you can play with these values. I don't know, I like this 16:9 because then we have perfect squares. Maybe reduce this a bit and then, yeah, change the amount in positive or negative direction. You could also use different textures to control this one here. For example, we could just very quickly create a circle to displace this one. So circle would be just the length of our signed normalized coordinates. We can also add the noise texture and multiply this by the amount. So did this one work? Yeah, it seems to be working. Now we have this weird circle distortion. Ooh, this is very trippy. So here you can see the output of this one. Yeah. You could also use other textures to distort this. But now that we invested so much time in our glass texture, I will just use this one. So yeah, this was essentially what I wanted to show you. Be sure to check out the videos in the description I used as an inspiration for this one. And yeah, I hope you found this useful. Thanks for watching.